Hello everybody, welcome to this webinar. I'm your host Abid Samhouri, and the topic for today's webinar is going to be Network Security Monitoring, NSM from Theory to Practice. This is your monthly webinar, and I would like to say that this is a recorded webinar, and you can find all the previous recording at the following link, app.livestorm.co/axon-technologies. So the agenda of today's presentation is going to be as follows. The first part will talk about the theory and the concepts behind NSM and the fundamentals and the essential element of NSM. And this will involve talking about indicators and warnings, because NSM revolves around indicators and warning. And then we'll talk about what NSM is not, because many people might compare NSM to other technologies like device management, for example, or IDS. So we'll talk about how NSM is different than other technologies. We will compare NSM particularly to IDS. What is the difference between network security monitoring and intrusion detection system? We'll talk about how escalation and response is an essential part of NSM and why it is an essential part. And then finally, what are the types of data that we need to collect and monitor in sophisticated enhanced NSM implementation? And these are the full packet capture and session data, host events, and network events. In the second part of this webinar, we'll talk about the tools, the open source tools that you need to implement in order to have an effective NSM working in your environment. And these tools are the Archime tool, and it's good for full packet capture, which is the first data that we need to collect. And then we have two open source tools for network events called Network Intrusion Detection Systems, NIDS, and these are Snort and Suricata. And then we will cover host-based intrusion detection system, the HIDS, and the open source tools for that are Asic and Wazo. We'll know that these are actually essentially the same thing, because Wazo was a fork of Asic. And then finally, we'll talk about the how to manage all the logs and all the data from all the previous collection points into one central management system for triage and investigation. and we'll cover two open source management system for that, and these are the OSSIM and the Elastic Stack. So let us start now with the first part, which is the background of NSM. First, let us understand an important thing. When security technology started in the beginning, they started as preventive, okay? And preventive was focused around how can I have a rule that prevents something I don't want in my network. And the first manifestation of preventive controls were firewalls. So you would configure firewall in a preventive mode and you say, okay, block this IP, block these ports, allow those ports and those IP only. And then you put that firewall on and you forget about it. You don't monitor it, you don't look at it. Only when you need to change a certain port or a certain IP, you go and tweak it. But aside from that, you simply trust that the firewall is going to block any IP address that you have explicitly defined or any port number that you have configured this firewall to block. So that was the initial thing. And then came later on detective technologies. And detective technologies, they want to monitor now what goes through that firewall and how to detect, and they try to actually try to find intrusions within the traffic that passes through the firewall. And the first manifestation of detective control was the IDS, the intrusion detection system. However, IDS has some pitfalls, some problems, and we can summarize this problem as follows. First of all, IDS is configured with signatures. So they have a set of signatures and they compare network traffic to those signatures. And if they match, then we fire up an alarm. Now, what happens if there's an attack or an intrusion that there is no signature for yet? Okay, what would you do? The IDS simply will not see it. Okay, the IDS will simply like assume it's a normal traffic, so it will not fire an alert or alarm. It will not say anything. The other problem with IDS is false positives. So sometimes it can flag traffic as a threat or intrusion, while in fact it's legit and it's fine. So we have these two false positives. We have these two pitfalls in general. Now, IDS vendors started to add preventive layer on top of IDS, and they created the IPS, the intrusion prevention system, and they put prevention and detection into one product. And this is like, from security perspective, this is not really a good practice, because when you detect something, you need another third-party element or product or a person verifying what is being detected and flag it with enough context and enough information to actually flag it if it is true positive or false positive. In addition, when IPS like flag something with a false positive, it's now the problem is the problem is bigger now, because it's going to deny legitimate traffic and causing denial of service. So an IPS with a false positive is going to cause trouble now. So we evolve from those. We have the problem that if we don't have a signature for it, then we cannot really we cannot detect it. And if there is something that the IDS cannot see in particular, then we cannot detect it. Okay. Not only that, assume that an attacker manages to get inside, and then after a few weeks, you tweaked a signature, and then you caught something, a malicious activity at one point of time. With IDS, you don't have enough information to actually go back for the last month and try to to trace the attack from its initial axis. So there is no backward looking. There is no history here. All of these problems caused us to invent the NSM, the Network Security Monitoring. So NSM now comes along and says, I would like to be 100% able to detect any intrusion, even if I have no signature now for it, even if there is nothing that indicates of it now, but maybe 1 month down the road, okay, I have a clue about that attack, and I should be able to find it and to detect it. And so with NSM, every single intrusion, no matter how sophisticated it is, ultimately with NSM, I have traces and I have indicators of it. The only requirement here is how to do a proper analysis to unveil it. So with NSM, if there is an intrusion that I am not able to detect, it's not because a failure in the system, it's because I haven't done enough analysis yet. But with enough analysis, I am able to find it and to detect it. And the most agreed definition upon NSM is as follows. It is the collection, analysis, and escalation of indicators and warnings that detect and respond to intrusions. Okay, so we have 3 elements here in the beginning: collection, analysis, and escalations. Okay, they happen in stages. Okay, first you collect, and then you analyze, and then you escalate of 2 things. And these are the indicators and the warnings. And with indicators and warning, you're able to detect intrusions and to respond to intrusions. So it is a holistic way of threat hunting. We can put it this way. It is a holistic way of threat hunting. What I need to do, I need to collect, first of all, enough information that will give me visibility across my infrastructure. Okay, we'll talk about those enough information and why. And with enough information, I can guarantee that any intrusion can be detected. Okay, and not only I can detect, once I detect it, I am able to scope it. And by scoping, I mean I am able to understand its origin, its impact, its scale, what it affected, how did it start, who did it, who started it, and once I can scope it, then I can respond to it in a very efficient manner. Okay. So let us focus a little bit on indicators and warnings. Okay. We have now products then, we have technologies, we install something somewhere, okay? And those technologies perform the collection of enough data, the collection of enough information. And this technology is programmed, okay, is programmed to produce indicators, to produce flags, to tell me what's going on with my network, okay? And then a human being, somebody who is a specialist or security analyst, will come along and analyzes those indicators that are coming out of the technology, coming out of the product. And once they analyze the indicators, now they can make a judgment, and this judgment is the warning. So they can say, okay, we might be under attack, or this server might be compromised. And the human now, the human analyst, will escalate that warning to the higher level. And then if the warning is verified that there is really a compromise, another phase starts, which is the incident response. So indicators are traces of an attack, traces of events, okay, that may raise any suspicion. But indicator alone is not sufficient. A human being need to translate the indicator into a warning by giving it a context. Let's look at an example. A technology, a product I might have, like let's say intrusion detection system, an IDS or HIDS, will tell me TCP traffic contains the string bin bash, okay? And we know that bin bash is the shell terminal that is requested by hackers when they compromise the system. But then a human being will come along and interpret this indicator as a warning and says the server might be compromised. Now there is a chance that an administrator is doing a legitimate bin bash traffic and he is accessing a shell remotely. So in this case, the indicator is not really a threat. Okay, so this is the difference between indicators and warning. Once a warning gets escalated and then we verify and it is confirmed that there is a compromise, a huge procedure, a long procedure starts, and this procedure we call incident response. Okay, an incident response needs to go now and try to remediate and recover from the attack. Incident responders will also rely, just like the analyst who did the investigation and the triage who did the verification of the indicator, the incident responder will also benefit from the NSM in scoping the incident. So the incident responder can ask questions like, what did the intruder do? When did he do it? Is he still present? Does he still have access right now? And what is the impact of that intrusion? What damage did it cause? In NSM, because I have collected enough information, I am able to go back in history. I am able to go back like 1 month ago and check the data that I have in a certain way, that is parsed in a certain way, and then I will see the elements of the attack over there, no matter how sophisticated. Even without a signature, I can still find traces of the attack and I can put the pieces of the puzzle together so that I uncover the attack. In NSM, we do not care much about how the intrusion is detected or who detects the intrusion, unlike an IDS, for example. The analyst, he will gather indicators from as many devices as possible, from as many sources as possible. So the NSM analyst might find in one intrusion, he might find the hint to the intrusion through a firewall log. In another intrusion, he might be checking native flow logs and then find a trace of that intrusion. In the third scenario, he can be checking Windows event logs and then he will find a trace of the intrusion. So it doesn't matter from where he gets it, but he gets it because he is collecting enough information. He has visibility over what's going on in the enterprise or in the network. Unlike security professionals who only rely on IDS, simply like they would install the IDS and forget it, and they rely on it to give them indications of intrusions, their source of information is based only on IDS. But in NSM, anything can be a source. Anything can give you a hint of an attack. Let's talk a little bit about context, because NSM also put emphasis on the human being who is doing the monitoring. It's not only enough that you have technologies in place. If you don't have somebody, a human being, a human mind, looking at the collected data and doing the analysis, we're gonna miss big things from an intrusion, and we can have a lot of false positives. And this is what technologies don't have. Technologies lack context. Context is the understanding of how a particular event, security event that's taking place in the network, how is it related to the entire organization. Okay, I'm gonna give you an example. We can put a signature, an IDS, or a rule in a security product, okay, that says whenever we see PS exec traffic on the network, flag it as a hacking incident. PS exec is a tool that allows you to connect to Windows machine and execute different commands. Okay, so and hackers use PS exec a lot when they do lateral movement. However, imagine an administrator using that tool to access his own servers, and for a technological product, this seems like a hacking incident. I will simply raise an indicator or a flag or a warning that this is a hacking incident. But if there is a human being behind it who understands the relation between this incident and everything around in the network, he would know that this is actually a totally legitimate action. So with NSM, it's very important you have the human element to it. So what NSM is not, okay? And some people might confuse NSM with other things. NSM is not device management, okay? In many IT infrastructure, many IT engineers or IT administrators, they might have monitoring software to monitor the uptime and the bandwidth of their network, okay? This is not NSM. If you are monitoring the performance of your links, of your routers, of your devices, of your servers, their performance, their usage, their uptime, etc., etc., this is a good thing, but this is not NSM, okay? And network security monitoring, you focus on monitoring indicators that when you analyze them, they can lead you to a compromise. They can lead you to intrusion, okay? Another thing, NSM is not security event management. A SIM solution that you can have in your network, okay, can aggregate logs from different sources, okay? It can give you alerts of certain things, okay? Again, this is good, and NSM benefits from having a SIM and a SIEM. In fact, a SIM solution will make NSM much easier to do and to effectively implement. However, NSM in itself, SIEM in itself is not NSM, is not enough to have a complete NSM. Because in NSM, you need to actively analyze, sometimes even in ad hoc manner, the logs and the data that you collect from various sources, okay? In SIM, you're simply managing the logs, okay, in a very automated way, and relying on whatever being produced by a SIM solution. SIM solution must be incorporated on NSM, but NSM is larger than SIM or security event management. NSM is not network-based forensics. Digital forensics in general, whether it is network-based or host-based, is a legal term. It is concerned about preserving evidence for a court, chain of custody. It has a detailed procedure to be done for legal purposes. NSM is not a legal thing in itself. NSM can help forensics investigators, but it is not in itself a forensics thing. Finally, NSM is not intrusion prevention. As I said earlier, IPS, they have put detection and prevention on one device, and from NSM perspective, this is not a very good practice because detection and prevention should be done by two separate entities, like two separate products or two separate teams or two separate individuals. Because with detection, you have its own procedure, and once you detect it and then it is confirmed that it's not false positive, then you can write the signature for it to be added to the preventive control. Again, always there are attacks that can circumvent preventive control. So no matter how sophisticated you have your IPS or any preventive measure you have, there will be an attack at some point that will evade preventive measures. NSM catches those things. Your preventive control might not catch those sophisticated attacks, but with NSM, you can catch them. Maybe not now, maybe not in real time, but you will catch them later on because you have enough data about what's going on in the network. So, what do we collect? There are different things we can collect for a sophisticated NSM, okay? I'm gonna focus on 4 types of data that we need to collect, okay? But there are more, but these 4 are the most important, or the large categories of data that we need to collect. The first type of data is full packet capture, okay? And this is could be the most important and the richest form of evidence or the richest form of indicators. And full packet captures mean the following: that every single packet that traverses my network, okay, I capture it as it is from beginning to end, with all its headers, with all its data, with all its OSI layers. So I capture it from the Ethernet layer all the way to the application layer. So I'm storing the IP layers headers, the TCP or UDP headers. I'm storing the presentation and session headers. I'm storing the application headers or any payload that's being attached. So the entire packet is being saved. And this is the ideal scenario. Now, there are some challenges because storing every single packet in a network require, number one, a huge disk space. And if you have like a very high bandwidth network, sometimes you need very sophisticated hardware to process all those packets. So sometimes you need to make a little bit of compromise here, and you need to focus on which network traffic that you need to capture in its full in its entirety. Okay, so you might focus on packets within, let's say, the server segment, or packets within the DMZ segment, or packets that go to the internet, to the outside world, inbound or outbound. But the ideal scenario is preserve or capture full packets to what your disk space may allow, and preserve them and keep them in storage for as long as you can. Okay, so the more you collect is better, and the longer you store them is better. There is something called retention period that usually after 3 months or 6 months, the entire storage gets overwritten. Okay, again, because of disk space, but the longer you can, the better. And if, for example, at certain aspect of your network you cannot do full packet capture, don't eliminate it completely from your network. So if you have a very high bandwidth segment in your network that you cannot do full packet capture, at least do full packet capture somewhere else in your network and capture session data on that high bandwidth network. With full packet capture, you have access you can derive a lot of data. You can derive session data, you can derive statistics, you can even derive alerts, because it is really the base of so many other analysis tools. So a network intrusion detection system would rely also on a full packet capture. With full packet capture, let's look deeper. We can achieve two things. We can achieve what we call a granularity. And the granularity means I'm collecting every single bit of a packet. Now imagine the following. Imagine a hacker who is doing command and control, who picked certain types of IP header or TCP header, certain types, certain bits within the headers that is usually unused, or if you manipulate them in a certain way will not affect the communication. And he started to use those bits to send his own commands and his own data to exfiltrate his data. If you are not capturing the full packet, and there is no signature for this particular tool that he's using, then you're gonna miss that attack. Okay, then you're gonna miss it. Not only that, if you discover it in the future, like for example, if 1 month from now you discover that there was an attack, you cannot really scope the attack because you don't have the packets. But if you are implementing full packet capture, you can always go back to these saved packets and investigate the headers and investigate the bits, and then at some point you can reverse exactly the intrusion that happened. So collecting metadata or simply relying on headers is not as complete or holistic as full packet capture. The second thing that's also important with full packet capture is I will have access to the application protocol data, and this is called application relevance. If I capture only the session data, the IPs and the port numbers and the payload size, then I might not have access, for example, to the files that are being transferred over FTP or HTTP, okay, or chat messages and so on. The second data that is very important to collect is session data. And session data here, first of all, it relies on full packet capture. So if you have done full packet capture correctly, you are able to derive session data in a very sophisticated way from full packet capture. But sometimes you can even derive session data without having full packet capture. So there are two ways to have session data. But what is session data? A session is a stream of communication between two machines on IP addresses, on the same IP addresses and the same port number. So within a session, you can have multiple packets. So if I establish TCP connection between my machine and Google server, and then I issued a lot of GET requests and I get a lot of responses, all of those packets, the GET and the POST, are within a single session. So a session is a stream between certain source IP address, destination IP address, source port number, and destination port number. So I collect this information with the timestamp and the number of bytes exchanged. And this is the essence of what's called NetFlow. NetFlow, created initially by Cisco, extract those data from network and save them. And you can have a lot of statistics about them, and they are helpful. So at some point where you cannot have full packet capture, a session data, session statistics will give you some clue about your network. So you can understand from session data how the network behaves, for example, in the morning during office hours or after office hours or midnight. And you can see, for example, with session data, any spike of activities that you can see sometimes during at night, for example, you can see a spike of data. It will give you indication that something abnormal is taking place. So session data will complement full packet capture. Okay, and as I said, there are two ways to collect session data. You can either perform full packet capture and then analyze the full packets and derive from them session statistics. This is one way, and this is the ideal way because you always have the full packet capture behind them. Or where you cannot have full packet capture, you are simply counting statistics about the traffic as the device is monitoring this traffic. And this is how NetFlow works. And in this second case, you don't have the full packets. You have the statistics, the session data, but not the full packets. It's always better to combine session data with full packet capture. The third type of data that I need to collect are the network intrusion detection system, the NIDS. Okay, so I would have a NIDS somewhere on my network, monitoring all my traffic. Okay, and then based on the signatures built into the NIDS, is going to generate alerts. Whenever it sees something that's matching the signature, it's going to generate alerts, and I need to collect those alerts. Okay, along with the session data and along with the full packet capture, okay, and analyze them. So imagine NIDS will tell me that somebody is doing port scan, okay, and then I see some statistics. I can verify the NIDS alert now by going to the session data and checking the statistics in the session data, and I also can go to the full packet capture in order to verify extra thing within that port scan activity. Or for example, I see an indicator about command and control from the NIDS. I can go to the session data or the full packet capture to verify the command and control further. So it's going to enrich the NIDS alerts. There are different tools that perform network intrusion detection system. Open source examples are Snort, Suricata, and Zeek. And you can install NIDS around the network. You can have something called sensors in every segment, and then the sensors aggregate all their data into one console or one NIDS management system. The fourth type of data that I need to collect is the HIDS, the host-based intrusion detection system. And what's going on each machine is as important as what's going on the network. In HIDS, you have an agent that gets installed in each endpoint, whether it is server, whether it is a laptop, whether it's a user machine. And then the HIDS agent monitor Windows event logs if it is a Windows system, or the logs in the var directory on Unix and Linux systems, and then perform certain analysis for these logs. And again, it has signature just like the NIDS, and it can, for example, attempt to detect, for example, unauthenticated access or a failed password, or a brute force attacks, privilege escalation attacks, etc. So a privilege escalation attack, for example, might not leave a trace on the network, but if you have a HIDS, you are able to see it or detect it. The same, for example, for malware, it can have signature for malware. Also, HIDS can perform what we call file integrity monitoring, FIM, where you would, for example, if you have sensitive documents on your machine, you can instruct it to monitor those sensitive documents for any modification. So if there is anything that gets modified on those documents, it's going to alert you. It's going to tell you, for example, this file was undergone a change at this particular time by this user account. Again, all the HIDS on all the HIDS agents on all endpoints will send their traffic or their alerts to one management console where you can monitor them. So these are the four types of data. So you have the NIDS, the HIDS, the full packet, and the session. If you consolidate them all, and then you do analysis of those types of data, you have a great visibility of what's going on in the network. All you need now to do is to perform some detection engineering and maybe some ad hoc detection way, and then from there try to generate warnings whenever you see certain indicators of compromise. This was the first part of the webinar, where we talk about the concept and theory and how it should be done of NSM. Let's move on to the second part, which is the open source tools that are relevant to NSM. Okay, what are the tools in the market? And these are open source, so you can download them and play with them in your virtual machines, or you can have them in your lab environment or a testing environment. So I'm not going to cover any commercial tools here, but there are also commercial tools if you want to find commercial ones. So for full packet capture, if you are in the network field, in the IT network field, I'm sure you know about a tool called TCP dump. TCP dump, even though it's great, okay, it used to be a tool for full packet capture, but because it's a small scale, it cannot handle large environments, people invented other tools for large scale environment. And one of those tools was called Moloch in the past, and now it's been updated and now it's called Archime. And this is a very, very sophisticated full packet capture. It's open source. And when it collects packets, it doesn't only store them as they are in text files or even binary files or PCAF format files. It does indexing. And when it does this indexing, it makes searching the packets easier. Okay, so it provides you even with an interface, HTTP based graphical interface, where you can see all your packets, and then you can search them. And the good thing about Archime is it can even give you session data at the same time. So it generates session data from the full packet captured. Okay, so you combine two elements into one product. Let me show you a demo on Archime. Here is a snapshot of how it looked like. Okay, this is the sessions pages. So it groups packets into sessions. So each line here is one session. So we have one session between source IP here and destination IP, and source port number and destination port. So you can see this is HTTP. Okay, and within that session, we have around 6,400 packets. And if you click on the green plus sign here, you can expand and you can download even all these 6,000 as PCAP and open them with your favorite packet analyzer like Wireshark. Okay, and it gives you here statistics, and there is even a search bar over there where you can search by IP, by port number, by content, etc. And it also gives you the URL that was contacted for this session. You can also find DNS packets, DNS sessions, and DHCP, etc. It also has a way to graph the connections. So in a simple graph, you can see, for example, that this IP communicated individually with all these IP around it. You can see, for example, that this has talked to this, and this has talked to this. So you can, in a visual way, like stars and circles, you can know how the sessions are being distributed across your network easily. So you can know visually which IP address has done a lot of packets, resulted into a lot of sessions, a lot of packets, and so on. Let me see if I can show you a demo here. And this demo is actually online on their website. This is their website, archime.com. So this is a demo account on their own website. So as I was telling you, you can find here, let me expand this a little bit. You can find here the sessions and you can expand, for example, this is, for example, a DNS session between two machines. And if I expand, I can even find more data about that session. And one thing I want you to notice, guys, is the community ID. Community ID, you're gonna find it later on, even in Security Onion. Community ID is a hash of the sessions element of source IP, destination IP, source port, and destination port. All combined together will give you a single community ID. So if you search by community ID, you will find all relevant information to this particular sessions. It can tell you that this session, for example, uses DNS over UDP, and there is only one packet coming from the source to the destination, and one packet from the destination to the source, and the size of the packets, and then it will break down the parts of the packets at the Ethernet layer, at the IP layer, okay, and also the payload, the size of the payload. So if we take another session, for example, let's take port 80. This is port 80 here. There are 11 packets. And as you can see here, download PCAP. I can download the PCAP here, and it's gonna download a file that I can open in Wireshark, and then I can view all the 11 packets within this session. Okay. Let me go back to the slides. The second tool I want to focus on here, or I want to mention, is Argus tool. Argus is a tool, it's an open source tool just for generating session data. And Argus is a command line, okay? It has no graphical interface. It's very old. It was like probably the first session data tool that was invented in the 80s, but it's still well maintained until today. Maybe its only drawback is it's very manual and it is command line. But this command line can actually generate the graphs. So you can script those commands to generate graphs about what's going on in the network. It works in a client-server architecture. So the server will process network flows and generate data, and then the clients would actually process the session data in order to generate something for you as an administrator. It has two ways. It can either capture traffic live and generate the statistics about the session while it is capturing traffic in real time, or you can feed it already captured packets that have been captured before. You can feed it into Argus, and then it will generate statistics about it. Here are examples of the graph that can be generated by Argus again. So you have to write command lines, sophisticated, like sometimes difficult to remember command lines, in order to generate a graph about what's going on in the network. For example, about the bandwidth usage of a system, or the sessions concentration of a system in a graph like this. But again, if you use, for example, Archime on its own, Archime will give you session data without the need of running Argus. Let us now move to the HIDS, okay, the host intrusion detection system. And there are two two open source heads, and one of them is OSSEC. It is by far the most popular one, but it's not really the best. The best is Wazo. I'm going to talk about it in a minute. You can download OSSEC again in a server client way. So you have the client, which is the agent, and you can install it on different platforms. You can install it in Windows, Linux, you can install it on Mac. And then it reads all the logs on that system. And it has like a database of signature. And based on the logs and based on the signature, it can fire up some alerts for you. It can analyze processes and files and try to find signatures of malware. It has an active response. An active response is you can tell OSSEC that whenever it generates, for example, a certain type of alert, to go and isolate the machine from the network. Like, for example, if this alert is something that is severe, for example, go and block that system, isolate it from the network, or you can, for example, give it a username and password authentication credentials to access the firewall, and then it can make changes on the firewall based on those alerts. This is called active response. It can also perform file integrity monitoring. You can give it a set of files to monitor, and whenever there is any change on those files, it's gonna give you some alerts. Another tool is Wazuh. Wazuh was a fork from OSSEC. So the creators of Wazuh, they took some version of OSSEC in the past and they enhanced it. Okay. The only problem with OSSEC is it's a small scale. So if you have got really a large enterprise that deals with like hundreds of thousands of machines, and that has very high bandwidth, sometimes working with OSSEC is not very sophisticated at that level. So Wazo was designed with scalability to handle very large environments, very high bandwidth, and it has a very real-time graphical interface where you can search alerts, where you can find things in real time. It also can be used as EDR, endpoint detection and response, meaning if you want to actually, you can see all the information related to events in a very connected way. Instead of seeing, for example, separate events as unrelated, an EDR here can actually combine all these events in a very chain way, timely fashion, so that you can detect attack in a very smooth way, and you can even respond to an attack. So you can see that, for example, a certain file was downloaded by Firefox at this time, and then Firefox was spawned by, let's say cmd.com, cmd.exe at this particular time, and for example, and then the malware downloaded by Firefox was a PDF file, and then this PDF file opened the command and control session with an attacker. So Wazo is very sophisticated heads. Okay, so if you want to use a heads, use Wazo instead of OSSEC. It has agent and server components. The agent would check all the log and events and collect them. It can also check the registry keys for integrity monitoring. It can check all the processes and applications. It can monitor also. It can perform something like vulnerability assessments and detection of rootkits. It can also do configuration assessment and policy monitoring. So if the endpoint doesn't meet your configuration standard, it can flag something, and it has a beautiful interface here. And the server analyzes all the data that has been collected, and whenever it sees indicator of compromise, it can raise alert. Again, it can collect data from hundreds or thousands of agents. So we covered the HIS, we covered the host-based intrusion detection system, we covered the OSSSEC and the Wazuh. Okay, my favorite one is Wazuh, of course. Let us move to the network intrusion detection system. And network intrusion detection system, the most popular by far open source nets is Snort. Okay, here is its homepage. You can download it, and it has the signatures that you need to run, because when you download Snort by itself, it has no signatures. Okay, so it only monitors traffic for nothing. So you need to add signatures, either develop your own signatures or you can download signatures from the internet. There are 3 levels of rules or signatures. The first one is community rules, and these are free and available to everyone. You can download the zip file from the website and then integrate it into your Snort, or you can register an account at the snort.org website, and then you will have access to some extra rules and signatures, or you can subscribe and pay some annual fee, and you will get even privileged signatures. The problem with Snort is it doesn't have graphical interface. It's very sophisticated, but it writes all its alerts to a text file. Okay, for example, you can configure it to write to something like NSM/Snort/alert, but then it's not very convenient to monitor text files for alert. So usually people integrate Snort or integrate a third-party app that filter through or extract and read the text files, okay, the alert text files, and then present them in a graphical interface. And one such software in the past was called Sguil, and or Sguil. Sguil or Sguil, depends how you pronounce it. And Sguil would provide you an interface to the Snort alerts. However, Sguil, very hard to set up. It has a lot of bugs and a lot of requirements when you set it up. Some people have invented additional other alternatives, and one of those alternative we're gonna look at in a while is the security onion platform. So security onion platform will give you a very nice sophisticated graphical interface that works on top of Snort and also can integrate data from Wazuh and from OSSSEC. Suricata is another network intrusion detection system. Okay, even though it is not as popular or widely used as Snort, it is actually outperforms Snort. So it's better. It is compatible with the Snort in terms of the signatures and the rules and the way it writes data, but it has additional features. Suricata was made as an IDS for network security monitoring. So it can sometimes capture full packet capture, but not all packets. Only certain packets it captures them if they are related to its alerts. It can log, for example, HTTP requests. It can log all DNS requests. It can extract certificates, SSL certificates of the wire, and store them so you can view them. It can even extract files. So if it comes across like HTTP communication and there are files being downloaded from the internet, it can extract those files and put them in a directory. So you can see images, you can see MP3 files, you can see exe files, PDFs, Excel files, etc., etc. It's also very optimized for high performance. Again, for very high bandwidth, multi-gigabit per second traffic, they can be detected. And Suricata can be integrated with other tools to view the alert. So in itself, natively, again, it does not have graphical interface, just like Snort, but you can integrate it with other tools. You can integrate it with EveBox. Evebox is a web interface that was designed to read Suricata alerts and present you in a very graphical interface way, in very graphically appealing way, as you can see here in this screen. So you can shuffle through the alerts, you can filter them, you can search, you can escalate, etc. You can even integrate Suricata with a Splunk SIM and Splunk Enterprise. In a Splunk store, you can download Suricata plugin, and then it will be able to read Suricata alerts from a database or its file, and then show you statistics and show you all the alerts in a parsed way. You can integrate Suricata with Elastic Stack, and we will talk about Elastic Stack in a while. It's an open source search engine that you can have, and it's a search engine made particularly for security monitoring. So you can integrate Suricata into the Elastic Stack. Now I'm going to cover two types of technologies, the last two open source tools that can be used as a SIEM and as a search engine that collects all the previous data. So if you have nits, you have hits, you have full packet capture, you have session data, etc., you can feed it into a management system that can centrally manage and that can allow you to investigate and to analyze those alerts from all these different sources. One such system is OSSSEC, developed by Alien Vault, now called AT&T. It's open source, and you can feed it nits. It has already built-in Suricata plugin, so it has already a built-in nits. So you only need to route traffic to the sensor, to Alien Vault sensor, and then it has the nits rules, and it will do all the processing. It can also be integrated with OSSSEC heads. So you would install OSSSEC on endpoint and then ask OSSSEC to send the logs to the Alien Vault OSSSEC. You can also send syslog messages from devices, firewall, and other routers and switches to the Alien Vault. And then it has detection rules that does correlation, so it can provide some high-level alarms. The final system is the Elastic Stack, okay? Sometimes called Elastic, sometimes it's called ELK Stack. And it's an open source search engines for security logs, for security data. And there are three components to the Elastic search engine. The first component is the log stash, okay? The log stash, it's a data processing engine. So if you have OSSSEC somewhere, or you have Suricata somewhere, or you have Wazuh somewhere, you can ask those agents to send their logs to the log stash server. So the log stash will take those logs, process them, and then store them in a certain storage, okay? And then the Elasticsearch, which is the second component now in the ELK stack, would actually parse all these logs, okay, and index them for you to search them, okay? And Elasticsearch by itself doesn't have any graphical interface, so it works as a daemon in the background. In order to have a graphical interface of the data and see them and perform the searches, the third component, which is the Kibana. So Kibana is only graphical interface, web-based interface, where you log in and then you have access to Elasticsearch. So through Kibana, you would send your search query, and then it will pull the results from Elasticsearch and display it to you with the graphs and the statistics. This is the last open source tool. Now, as I mentioned before, the last part of this webinar, we will talk about Security Onion. So we're gonna have only 5 or 10 minutes before the closing. Security Onion is a platform designed for network security monitoring. And I have it installed here on this VM. And then I will access it from the web browser. So when you access it in the beginning, okay, you will see here this menu, okay, alerts, hunts, PCAP, grid, download, okay, and some other tools, Kibana, which is the Elk Stack, Grafana, CyberChef, all right. And one of the most important window here is the alerts window. So alerts is going to provide you the graphical interface of all the alerts, of all the logs that you have ingested into Security Onion. So Security Onion has a built-in network intrusion detection, NEDS, which is Suricata. It can even understand traffic coming from Wazuh and OSSSEC from heads. It can also work with the Snort. And then it provides you graphical interface after analyzing all the events and all the alerts. Because as I said, Suricata, for example, and the Snort, they write their alerts in text files, but with Security Onion, you can view them visually. And here, for example, we can see that some alerts are generated by OSSEC, some others, OSSEC, which is heads. And this could be Wazo, by the way. So Wazo and OSSEC have the same module. Suricata means we have collected those alerts were generated by network intrusion detection. So we have some Suricata, some OSSEC. And then for each alert or alert type, actually, for each alert type, like if I take this one, NetBIOS SMB Unicode shared access, has 46 alerts in this group. So I have 46 alerts of the same type, and if I click on this number, I'm gonna drill down into those events. Okay, and I can see the source IP, the destination IP, source port, destination port, and the category. And I can acknowledge it, like if it is false positive, I can simply acknowledge it and it will disappear, or I can escalate it for investigation, and then I will have an incident response case from that. And if I want to see more information about each of those alerts, I have it all parsed here. So if I scroll down, I can see the rule, which is Snort rule or Suricata rule. This is the signature that generated this alert. And I can see other parameters around it, including the very protocol itself or the very message itself that was captured, okay? And the community ID, and if you remember the community ID, it's a hash of the session data of the source IP, destination IP, source port, and destination port number. And bunch of other information. Now, from Security Onion, I can access Kibana. So in addition to that, Security Onion has a built-in elastic stack of Kibana, Elasticsearch, and also Logstash, and I can access it, and I can search through this data as well. And it parses the data. It has its own nice way of parsing the data. So this is the elastic component Kibana that I mentioned. It's a graphical interface, and Kibana accesses the Elasticsearch engine that does the actual search. So it pulls them from Elasticsearch, and then it will display them on the Kibana interface. If I expand this to last 30 days, I can see some more traffic or more alerts. You can see here something called module. Each type of data that I collect has a module to parse it. So there is a module to parse OSSSEC logs. There is a module to parse Suricata. There is a module to parse OS query. I haven't talked about OS query, but it is it's also for it's similar to host intrusion detection system. It's for monitoring endpoints basically, and you can query them for information. And Zeek is like Suricata, so it's another intrusion detection system. And then I can, for example, dive deep into one of those modules. So let's say I'm interested in network attacks. So I can click on Suricata here. So I will see only now its alerts, okay? Suricata alerts. You can do the same for OSSSEC. So you will see only OSSSEC or Wazuh alerts. Okay. So I have 48 logs related to Suricata, and I can see the source IP here, the destination IPs, and how many alerts for those IPs. Okay. And the destination port number as well. So I can dive deep into the type of traffic, like for example, the port number. I can search by port number. I can click on 80 and dive deep. So it's a very sophisticated way to search network intrusion detection system alerts. Okay, by IP address, destination IP address. You can even search for content at Suricata. Another tool I have at Suricata, Grafana. Grafana is very interesting interface. It will give me statistics about the performance of Security Onion. So if I want to know how my Security Onion is behaving, I can check the Grafana interface in terms of uptime, CPU usage, memory usage, disk usage, okay, swap, input, output, and so on, management interface. So it's about the performance of the platform itself. CyberChef is a cryptography tool. So I can cryptography, whether it's encoding or encryption, I can encrypt and decrypt, encode and decode based on many forms. So if I have a hash, for example, let's say I have a hash over here, or if I have something like base 64. I'm trying to find if there is any base 64 encoded. Community ID. So if I copy this, let's see if this can be in any ways decoded here. And then I put from base 64. Okay, I got something, but again, it's unreadable because I need, it's a hash, and hash is a one way. So for me, hash, I cannot use it as a function here. But let's say I have, for example, my name, for example, Abid Samouri, and I want to base 64 it. So this is the base 64 of Abid Samouri. And then if I want to decode it, I can simply copy it, put it here, and then instead of 2 base 64, I can have from base 64, and then it will generate. So it's a good way. It has a lot of functions, base 64, hex, hexdump, and it has also different encryption. For example, AS. AS decrypt, encrypt with a key. Of course, you need a key to decrypt. So it's a very handy way to do cryptographic operations. And I'm going to talk briefly about the Hive. The Hive is for incident response. Unfortunately, we don't have enough time to cover incident response, but once you escalate a case, once you are sure about a certain attack or intrusion, you can escalate that to the Hive. And if you remember, I showed you here a button called escalate. So with the Hive, you can create incident response cases. And then it's a way it's an incident response management application. So you create a case and then you follow up until you resolve that case. So you can assign it to certain people. And so this button here, the exclamation mark, if you click on it, you will escalate. So let's say you want to escalate successful sudo to root executed. Okay, so somebody types sudo on the system and you want to escalate that for verification. You press escalate and then it will create a case for you in the Hive. Okay. So we can see here that a new case has been created. Okay, successful sudo. You click on it and you can manage the severity, etc., etc. You can add description, additional information, and you can follow up on it, and then you flag it, and then you follow up until you resolve it. Once you resolve it, you can even create subtasks within it, and then if you find indicators of compromise and what you have observed, for example, hashes, files, etc., you can add them here, and then you close them. So it's a way to manage incidents and to see what incidents are still lagging and what incidents to be completed. Finally, Fleet DM. If you remember, I mentioned a little something about OS query, where you can query, where you install an agent. OS query is an open source tool that you can install on endpoints, and instead of sending logs like OSSEC or Wazuh, you send the query to that system and ask it for information. So, for example, let's say I have an agent here and I want to query it, and the queries are similar to SQL. So let's say I want to extract all usernames from this node. I can say select all from users and then run that query. So it collects information and puts them in a database similar to an SQL database, and you can query them using SQL queries. So I have pulled out the username, the users from that system. And in the document, in the documentation of it, you can see many tables, what are the tables that are there and how to query them. This is basically it, guys. This is all I wanted to cover in this webinar. Really, thank you very much. I really appreciate your attendance and your participation. And as I mentioned, the recordings are available on the website, on our homepage on app.lifestorm.co. If you have any question, please write it on the chat. I'll be more than happy to answer you. Thank you, Fran. Fran is our marketing manager. She helps me market all these webinars, and she set them up on the live store platform. Shout out to her. Any more questions, guys? If there are no more questions, then we can close. Thank you, Khalid. Good to see you here after some long time. Thanks, everybody. Hope to see you in a future webinars. Bye-bye.